Today, we'll speak about the application of artificial intelligence on industrial solutions. Some companies lose their business advantage because they continue doing the same thing and don't realize that the world around them has changed. Sometimes it is a matter of moving from one technology to another and reinventing an old business. Yellow Pages, for example, has been replaced by online search engines such as Google. Blockbuster failed to invest its capital in the new web-based business model. It has now been replaced by Netflix. Internet and the availability of cheap sensors and processors determined the end of Kodak and the rise of Instagram. And remember that the Italian Yellow Pages, Blockbuster and Kodak were prosperous companies just 10 years ago. In other cases, the technology hasn't changed at all. Sometimes it's a matter of adapting the product to the new customer demands or paying attention to the market and targeting new needs. Red Bull was the first to sell the energy drink concept. Here the shift wasn't related to the product's technology, it was more about intuition and the discovery of a new business opportunity. Red Bull was the first to target this market and Coca-Cola lagged behind. Coca-Cola tried to remediate their error, attempting a recovery with the Burn brand. In a short while, we'll see an example of how deep learning and artificial intelligence can be used to discover new patterns and data to target new business opportunities. Another application in which the artificial intelligence will have a huge impact is the optimization of the manufacturing processes to achieve better quality and lower costs. The manufacturing systems are becoming more agile to enable them to adapt more quickly to market requests. The same production line will produce smaller product batches with differing characteristics. The requirements are no longer just about quality and speed, but also about production agility. The new data analysis systems should be designed to rapidly adapt to the varying production environment. Amazon, for example, has been working on big numbers from its birth to enable it to be competitive on prices. Now, the advanced automation helps Amazon in keeping the managing costs of its departments low. At the same time, the service is much faster and adaptable to the market requests. We are facing the fourth industrial revolution that will strongly modify our society. Most companies are adopting these technologies, and the first to successfully implement it will be the next business leader. The first industrial revolution began when humans started to use fossil energy instead of muscle power. The second was about mass production and line assembly. It was about the standardization of repetitive manual tasks. The third was the first automation wave in the 70s, where simple repetitive tasks were automated. And now we see the coming of the fourth and biggest revolution to date. This is happening now. The companies listed in this slide provide the fundamental software components to create advanced artificial intelligence applications. And these other companies integrate libraries to create vertical products for specific markets. Artificial intelligence can perform tasks that only a few years ago could only be performed by humans. The first industrial revolution replaced muscle power. The coming fourth industrial revolution will replace brain power. As soon as the major companies adopt these technologies, there will be an enormous impact on the job market. Repetitive tasks of progressively higher complexity will be automated as the technology evolves. This slide shows some results from research carried out by Oxford University. In this case, the telephone salespersons and keyboard operators are two professions that will be impacted by machines that can understand the human spoken language and relative concepts. This will allow the automation of call centers, customer care desks, and automatic translation. This is not science fiction. You have a working example in your pocket. Just check your Google Translate or your Apple Siri. Other jobs to be automated are those involving vision and handling. This is made possible by the artificial intelligence that can understand highly complex scenes in cluttered environments. Let's now see two demo videos that we produced an ad for. In the first video, we will see how artificial intelligence can recognize and classify objects in a complex situation. In the second video, the artificial intelligence describes a picture in plain English. Just try to imagine how these systems can help to organize archives containing millions of images. The development of this technology is unstoppable. There is simply too much money involved. NVIDIA was the best performing S.p.A 500 stock in 2016, delivering a 225% total return. It increased its market capitalization by $11 billion in just one day in November 2016, the day of its Q3 earnings call. The adoption of a disruptive new technology can be risky and requires investments. Our advice is to be cautious. There are many available software solutions on the market, but only a few of them will fit your needs. We are completely agnostic on hardware and software solutions. For this reason, we can help our customers in making the best choices. Maybe the best start could be to share some ideas with us, because the biggest risk for your company is a lack of information and not being prepared. Now we will see some examples of artificial intelligence algorithms that are readily available to be deployed on vertical solutions. This is just a partial list because these technologies can have a broad range of applications. Nevertheless, we think that these examples are significant. The first example is about finding anomalies in the data streams. This class of algorithms can be applied to a wide range of problems to find glitches in productive systems, unusual behavior in supply chains, financial systems, energy and communication networks. Finding an anomaly is important to allow adequate correction. For example, it can be used for predictive maintenance or to discover latent business opportunities in market data. In this case, we analyze the NYC taxi calls database. It contains the number of taxi calls hour by hour in the year 2014. The algorithm has been supplied with only the raw data. No other data, for example, holidays or special events, has been provided. Here we see the algorithms that start to analyze the data and after a while are able to deduct normal daily behavior and during the peak hours. When the behavior differs from the algorithm prediction, the point is defined as an anomaly and is plotted in yellow or red, depending on the anomaly strength. The first anomalies detected have an easy explanation. On New Year's Day, there is a peak of taxi calls just after midnight, and on December the 25th, there are very few calls. Remember that the algorithms do not have any information regarding holidays. It sees Christmas just as a standard day, and for this reason, it detects an abnormal pattern in the data. The second anomaly is detected for Halloween and the night after when people return home. The third anomaly was regarding the low volume of calls the night after Thanksgiving. It was probably due to a bomb threat spread by the news. What's strange is this anomaly detected on December the 6th. It's difficult to spot by eye, but here the system detected a strong glitch in data. Seemingly nothing special happened in New York City that day. After having looked back in the NYC news, we found this event that seemingly brought many unexpected visitors to NYC. Summarizing, artificial intelligence can watch data streams 24/7, finding irregular behavior, faults, and useful information to improve your systems and your businesses. The second example is about production optimization. In particular, we will see how artificial intelligence can use the sensors data to predict system failures. The most common way to supervise machines is to create dashboards for human operators. This approach has many limits. time and human attention, for example. Moreover, humans cannot supervise hundreds of data streams simultaneously. In this example, our algorithm controls hundreds of variables at the same time. Each variable on its own is meaningless. Nevertheless, we made a system based on a deep neural network that combines all of the variables to find the information we need. In this case, the graph on the left shows the raw variables, while the graph on the right shows that our system can predict a jet engine failure well in advance. Here, the deep learning algorithm finds 3 specific failure modes, indicated by the 3 red circles in the graph on the right. The last example is about using artificial intelligence to create new features and set new market standards. In this image, you can see a Nest thermostat, a company recently bought by Google, that set new standards for home automation devices. But today, I would like to present you with an entirely Italian example that explains how Ferrari was the first car maker to put an artificial intelligence system in its production electronic control units. Nowadays, this system is installed on every Ferrari model. This video describes the Sideslip angle estimator algorithm produced by Adfor and integrated in the most recent control system of high-performance and sport cars. The Sideslip angle estimator is a real-time software algorithm that can be integrated in any existing automotive electronic control unit. It typically runs in real time on low CPU resources. This algorithm uses exclusively the data already available on the vehicle's CAN bus, so no additional sensors are required. One of the most important features of our Sideslip angle estimator is that it's robust versus many parameters like tire size, tire conditions, and road conditions. This means that it's unaffected by the variation of these parameters. Moreover, our algorithm can be certified ISO 26262. The algorithm is based on new mathematical methodology, generally known as deep learning. This class of algorithms is widely used nowadays in computer vision and speech comprehension. We adapted the same technology to be used on our estimator. The creation of the mathematical model is quite computationally intensive and must be performed on a high-performance computing cluster. On the contrary, the mathematical model itself is quite light and can be integrated in any low-profile processor. It typically requires a fraction of the computational power available on a modern vehicle ECU. Please follow this link if you would like to investigate some of the topics seen in this presentation.